must go on.
Shall we start? Shall we start?
Yes.
Okay. Yeah. So the sort of
Got you there? Yeah.
Sorry.
Thanks,
Just
Teresa.
let me introduce Magnus Lindberg.
Yeah,
please.
just keep it very short.
Okay.
Yeah.
Thank you.
Yeah, so Per Magnus Lindborg, Seoul National University. Okay, so what is the color of that EA music? That was very inspired by this publication. What's the color of that music performance by Roberto Bressin? So he was interested in whether emotion in music can connect with a visual response. He was tasking musicians to play a simple melody with a particular emotional intent, and then seeing how this, how people would code that with a color in their responses. Now, cross-modal association it's been around for some time. I want to highlight the work that S.S. Stevens did in the 1950s. Very, very interesting work. So he was interested in all kinds of modalities, in particular sound, so loudness, how it maps towards visual brightness and pitch, but also things like the weight of an object and the taste sensations, the strength of olfactory and taste. So he was doing mapping from the physical measurable world to the psychologically measurable world, or these psychophysical laws that he discovered and formulated. There's two theories or hypotheses that we need to keep track of here. One is of it's referred to as the weak synesthesia hypothesis, launched by Gail Martirano from the 1980s, 90s. And the key point is here that the cross-modal associations, they are acquired. Okay, they don't exist in young children really as such, but in adults they are meaning-based. They're mediated through language, so semantically mediated and abstracted through a language network. They're also context-dependent. So you have to have multiple exposures simultaneously in a syncrecy situation, as Michel Chion would say, in order for us to learn these kind of associations. A bit more recently, the emotion mediation hypothesis, as advanced by Stephen Palmer in some works, and also in my own work, which I will very briefly talk about in a moment. So we can say that we have 4 different kinds or different levels of mechanisms in the brain, and at any one of these kind of associations can arise. So at the neurological level, the close proximity of 2 regions in the brain, just the fact that they are close, will mean that they have more exchanges going on, and that can be giving rise to structural correspondences. And at the perceptual level, we have the statistical co-occurrences, the proper syncrecies, which leads into the ecological perception, the ecological perspective. Cognitive learning, which is actually what Martirano was referring to, and then we have this level of the emotional, which I think is very heavily moderated by cultural exposure as well. So I mentioned this research that I did previously, color association with music mediated with by emotion. So I would just mention 1 or 2 things here. One is the response interface, CIELAB, and this may not be known to everybody. So CIELAB is a very interesting color space formulation. It's some 80 years of history, and it attempts to very closely match to human color perception. Very different from RGB or HSL or HSV, which are not really color spaces as such. They're they pertain to machines, not to humans. But CIELAB is very interesting, and you have 3 parameters. L is for lightness or brightness, if you want, and the A parameter goes from green to red, and the B parameter goes from blue to yellow. So in these experiments, here comes the second point, is that I only presented 1 color at a time, so not a whole color swatch. So people weren't picking a color, they were just producing a color through a physical interface while listening. So the task given to them was to match, using this interface, one color to the sound that we're hearing. That's for the shorter excerpts. In the longer excerpts, they would continuously trace the development of the music through the response of a color. I also had a size parameter, so there's 4 response parameters here. Okay, then let's go to the actual new research here then. So what's the color of that EA music? Long stimuli and short stimuli. So the long are pieces of music, and you will see the list there, and there are, most of them are of course very well known to people in the room here. There's 4 real classics by John Chowning, Jonathan Harvey, Jean-Claude Risset, and Trevor Wishart. And then I used 3 of my own pieces, and then 2 pieces by other composers of my generation, let's say. So it's Donna Martin and Jana Vinderen. So 9 pieces, and from them I also extracted 3 shorter excerpts within each one. So that's 27 short stimuli, and we had 21 participants or thereabouts. So I want you're going to see this kind of. No, I've used exactly 6 minutes. So this is what you're going to see, and it's a totally arbitrary spatial representation there. You just see the color responses. In the middle is the average. Yeah, it's the average. And participants, they would only see one color at a time. Okay, so with this, let's go to the max patch here. And I will play you a couple of examples from the Risset piece. So this is Sud from 1985. Here you will see the shorter excerpt, so kicking in. And of course I did this so that we can make a reliability test that the participants were given the longer context or the sort of shorter presentations, they would have, as a group, they would have the same reaction, the same response. Okay, and now in Risset's piece, it kind of changes texture, changes environment. Just a second. Okay, I'll stop there and just discuss these 2 parts here. The first one with a lot of blue, and it's not so strange. If we compare with, I'm going to play you that one, that's the same one, and that I also presented them with the pure soundscape recordings, and there is one water recording, sounds like this. So now you're mostly hearing the soundscape recording. Okay. So to the right there, very blue. And then the other example from Risset, we can find a matching recording from a rainforest with birds. Okay, so this is not so strange, right? We have, of course, Risset is working himself with soundscape recordings. And I think what I want to illustrate here is just the power of the ecological perception, that when we hear something, whether it is within the context of an abstract artwork or something else, this ecological perception, it kicks in very strongly, and it's the first thing that happens. If we recognize some elements, we will remember having been physically in such an environment, and we will make all kinds of associations to it. So water is blue, and forests are green. Okay, but then something happens in in Risse's piece, right? I'll jump a little bit to, I think, around to this point. So maybe you will remember what happens here. So it's a new musical element. Notice what happens with the color responses. Okay, so you have some kind of electronic sound, and it actually produces responses that are very towards the purple or magenta or deep red colors. And within the sets of the other 8 pieces, there's no other strongly purple response. So I thought this is a quite unique bit, that portion in Risse's piece. We'll listen a little bit further on. You will hear a quite distinct change in Risse's piece here for the last bit of the example. So it gets larger, the responses is one thing. And much more towards the red. Okay, we're somewhere we're somewhere there. And to compare with the examples from this corpus, I better check my notes. I'll just play one that I'm sure of. So here's one example from the start of Jonathan Harvey's piece, the Mortus Flying. Oops, sorry, here you go. So it's a similar color response, and then it's interesting to think about what is it that makes that, right? Okay, one other example is the from Chowning's piece, Estrella, entirely a synthesis. So after a little while, the respondents sort of stabilize towards a color, which is towards the very red. And the last example here, my own piece, extra quality. Okay, so what you hear there is, of course, voice samples. And as it turns out, voice is something that tends to trigger the response of red when you hear more or less individual voices. If you have crowds, then it gets more brownish, mustard colors. But there's much to be said about that. I'm going to go back to the slides and share with you this preliminary analysis, just focusing on the Risse extract. So here I've made a correlation analysis between some select musical features extracted from the signal, and then we have the 4 parameters of the visual response in the columns. So here we can see this is a distance correlation which compares the shape of curves. This is Szekely's algorithm. You should know that it goes from 0 to 1, so we don't know whether we have a Pearson positive or negative. We just know to what degree are such curves similar. We can see here that, or at least preliminary, we can observe that the size parameter in the response seems to be fairly strong relationships with signal features, and likewise for this A parameter, which is the green to red dimension in the color space. And actually, this would, I think, lead to a possibly decent prediction down the road. Okay. But if we look across all 9 excerpts, then they tend to cancel out, so we get much less prominent relationships when we have a larger corpus, and this has to have something to do with people using different strategies when they have different pieces reacting to. Okay, now that was preliminary, so I'm working on a proper time series analysis. That's pretty difficult stuff with vector autoregressive models, and a very interesting concept of the Granger causality, very used in economic forecasting, and this is, I think, promising for this kind of analysis to do, see whether actually the signal descriptors can drive the response, and Granger cause the response of people. Okay, now this is my last slide, I'm running out. So color association to music. I want to read to you this quote by the Swedish sort of father of music emotion research, Alf Gabrielsson. He says that music experience is a complex phenomenon. Different individuals react differently, and reactions to the same music may vary on different occasions. Many people find it extremely difficult to describe their experience. It seems to elude common vocabulary. Now, very much of music emotion research is semantically orientated with these semantic scales and so forth, but I'm interested in finding a robust method for non-semantic response methods for music perception and cognition. So hence psychophysiological methods, but also color responses, I think, are relevant there. This will allow running listening experiments with groups of people who do not have rich linguistic resources, or young children, aphasic stroke patients, or even normal people. It's just that they're not specialists, they don't have training in particular terminologies, for example. The third point is that I think this research can inspire graphic user interface design, particularly for audio software, to have color convey meaning in displays, or even in a Pro Tools session or something. And the fourth point is that we can do rapid prototyping of sonic materials by piloting audio samples from a visual control, so color control interface. And that's all I have to say, and I'm very happy to take one or two questions also. Thanks.
You had something like 28 subjects, was that correct?
Okay, so it's around 20, it's 21
right.
for one part, and then it's 22 for the other one, and
okay.
they overlap, so they are the same people.
How many times did they get to work through the same piece of music, and did you account for different times of day?
No, not at all.
Right.
Once only.
Okay.
But I recognize the point, and of course
It comes out of the Gabrielsson quote.
Yeah.
Again, a question about the participants. How much actual music did they listen to in any one session? How many minutes? I've got two questions. That's the first question.
Okay,
there's
so
a lot of music that
yeah.
you listen. I mean, it's like 2 hours if you put it all together. I know you took extracts, but how much did they listen to in one session?
Yeah, so they did it in blocks. So half of them did the long first.
Yeah.
So that's 3 minutes times 9, so 27 minutes of listening and responding. So that's a fairly long concert for non-experts.
Yeah.
And then in the other block, after some rest, they do the short excerpts. There's 15 seconds times 27, but also with a couple of other elements added in, such as those soundscape recordings.
Yeah, so they get breaks. Yeah.
They did got one break in the middle, just to clear their mind a little bit. Yeah.
Yeah. And can I ask my second question? The participants, were they all knowledgeable, shall we say? Was it skilled but knowledgeable in electroacoustic music, or were they man off the street?
Not exactly. It's a typical convenience sample of it's a mix of, I would say, half of them undergraduate students, and the other half are whoever's responds to the poster in the at the college.
Okay.
Yeah.
Okay, we should stop. Thank you.
Okay. Thank you.